There we go. Let's see. Yeah, I hope you're doing well too. You too, David. It's so funny because you were like, I wonder if it's a teacher thing to be proud of a quiz you made. I mean, I think administering a good quiz is important and a good thing to be proud of. It's better than being proud of like a bad quiz. Like I'm excited when my a quiz or something like that is obviously not easy, but like challenging, but students can actually still get it. Your school is using Canvas user right here, and you're making some fancy quizzes today. Yeah, online quizzes are good. They're useful, but I like to have my students draw things, so I still do them in paper if I can. And you're calling them knowledge checks because the word quiz is freaking them out. Yeah, it's very interesting. There is this whole line of research in education all about the words teachers, professors, instructors use and how that actually affects their students. So yeah, even like the word like quiz or exam that can like trigger the sort of like fear or anxiety response for some students, which causes them to perform less well than if that word was not used. I'm trying to think of some other examples. Um, well, like what? Oh, just like saying things like, oh, this will be easy for you guys. Like, uh, saying stuff like that as like an instructor is so hard not to do. But apparently, that primes students who are like maybe take would normally take like 3 extra seconds to think of the correct answer to be disappointed and perform less well when they don't immediately know the answer, like the in quotes smart kids. So I've been trying to purge language like that from myself. Another good one is like when a student gives an answer, immediately being like, "Yeah, wow, great, you did it." Uh, because if you're not consistent about that, then when a student gives a wrong answer, they feel dejected. Apparently, a better way to get better student responses over the long term is to like be fairly neutral. Like get an answer, say, "Oh, thank you for giving me that. Thank you for giving me that answer. Does anyone else have anything else?" And kind of wait till you get like a mix of right and wrong, and then talk about it. Anyways, it's really cool. So you love the new quizzes. I have not tried the new quizzes. You love the feedback option on Canvas, and the new questions match the new item types that your state test is going to. So you have to train them with the state exam. That's good. That's good. When you hand out their Fs, do you say your knowledge check just bounced? That's the opposite of what I was just talking about, David. That's purposefully antagonistic language, which I do find funny. But I feel like you'd have to have a good. I know you're joking, but I feel like you'd have to have a pretty good relationship with your students to pull that off. Um, what do you? Let's see. Even with grading, you've been wanting to move to a rating system of 1 to 4 for your level kids. Yeah, I love ungrading, like the idea of just changing well how we think of grading. Just because the history of grading itself is kind of wonky. It's interesting to read into. What do you call extra work you get as a punishment? Because one of your teachers used to call them learning opportunities. Uh, to be honest, I don't have work as punishment because since I work at the college level, it's pretty hard to be like say anything other than like, hey, you're, oh, hello, Samuel Animates. The boo is for grades. Yeah, grades are racist and misogynistic, and classist actually. Um, Hello, Megan. Also. That scared you. Uh, anyways, David, yeah, teaching at the college level, it's basically like, well, if you don't want to do this work, I can't make you. I will just fail you, and that's okay. So, all right. Um, so for those of you who missed yesterday or are not on the Discord and didn't catch this really quickly, I have a very open week, and I'm very close to unlocking the free tier of emotes for the community. So I decided to just do a bunch of random streams this week, except for tomorrow. Tomorrow's going to have a guest. It's going to be cool. It's going to be fun. Normal time and everything. Actually, maybe even a little early so we can get some extra time in. All about alien reproduction, alien human hybridization, that sort of thing. We're going to talk about some chromatin biology, that good stuff. But in the meantime, I'm just killing time on the other days. So I was just going to stream for maybe hour, hour and a half. Then maybe we'll find someone to pop over or two. You love aliens? I think a lot of people who join my stream also love aliens. Today, doing a little bit of very bad programming. This project that I had been working on, but have honestly kind of forgotten about, which means I also have to look back and see what I did, because I definitely didn't record very nicely what I did, is writing a program to take images like this boat and encode them into DNA. So I gotta figure out where I was with that. So quart to DNA, DNA to quaternary. I think what these were, oh, you know what? I actually might have taken notes on this. Please, did I take notes on this? I swear I drew something out and saved it for myself. Protein words. Huh. Maybe not. Yikes. That's tough. I thought I had notes on this. Because I kind of forgot my scheme. Because iteration 1 was short and easy and was awful, because it ended up having like... So basically what it was is I would take this image right here, this boat, turn it to black and white, convert all values to either 0, 1, 2, or 3, and then converted that to A, T, G, or C, and then I was good to go. Only problem being that led to things like strings of 20,000 C's. You've got a lurk, but you were curious to see what images to genes means. Yeah, that's, yeah. It's exactly what I said. I'm trying to convert images into a DNA code that we can use in DNA. I don't know. There's not really a point. It's just for fun. Also, I'm eating, so sorry. I'm trying to push the microphone away every time I take a bite, but I just got back from class. I'm very hungry. The only time you have ever given extra work as punishment was when you made the class draw glucose being broken down into pyruvate, because this one insufferable kid was being a pyruvate denier to the class, because obviously everything about biology, he knows everything about biology already from consuming all the YouTube videos he could as a 14-year-old. Excuse me? Yeah, what? Okay. Oh my god. Time to open up the internet and search what the heck pyruvate denier. You might have to explain this a little bit more clearly. Oh, that's what other Marcus, homozygote, nicknamed him because of how ridiculous this kid was being arguing with you about. I have never heard of pyruvate. You've made it up. Oh, okay. That is funny, frustrating, but also I'm a little bit sad that I wasn't going to find a series of YouTube videos saying that pyruvate wasn't real. Pyruvate isn't real. Um, yeah, I thought it was some scam pseudoscience thing to sell something too. Wait for this kid to get a little older. See, they're on the precipice. Oh, he's questionable. Uh-oh. I feel like he could be on the precipice of being like a good science consumer, but that's a little bit on the yikes side. Ooh, watches Jordan Peterson, but is very smart. Yep. Um, there is this someone, a professor I know. Uh, well, I feel like once told me her this hypothesis she had that every male in the United States goes through a phase where they are a little bit within the Jordan Peterson space. Not she didn't specifically say Jordan Peterson, but described an ethos of Jordan Peterson. His classmates roast him constantly for being a mega capitalist. Yeah, same thing, same thing. Hopefully he grows out of it. Hopefully he will get pulled out of the manosphere. Ooh, which reminds me. Oh, this has had nothing to do with programming these genes. That's okay. Me and someone in my not in my lab, but someone I know from lab in another lab came up with this beginning of a fantastic scheme. We are going to, so there's this dumb semi-internet myth that the Y chromosome is in danger. The Y chromosome is shrinking over time, and someday there will be no men, right? Oh, Megan, I will explain that one too. And we thought that is such a perfect inroad for pseudoscience bullshit to like make a ton of money off of the manosphere by like selling supplements that like protect the Y chromosome. We're gonna call it like Big Y or something like that. Um, I just feel like we could really, really corner the market on Y chromosome lengthening supplements. With a bunch of pseudoscience bullshit. Yes, and Megan is referring to another scheme that I had in grad school, which was a dietary scheme where the idea is that we promote the eating of the pure elements as a way to live toxin free and to prevent your body from having to spend its life force and energy to break down complex food or whatever. So we were basically going to advocate for like, you lick a rod of iron once every week, and like you eat, pure carbon or something like that. Yeah, you listen to a whole podcast where there basically is no regulation in vitamins and other wellness products. Exactly. The keywords are supplement and not FDA approved. And you have a free pass, more or less. You could just definitely put like glucose pills on the market and say lengthen the Y chromosome. Yeah, exactly. It's like so easy. Like we could go to Alibaba.com, my favorite place to like search random things. We want a supplement though. So I would say like ginkgo biloba, something like that. Um, like I bet we could buy like a barrel of ginkgo biloba supplements from Alibaba for a couple $100, repackage them, resell them. David, you've already got the slogan right there. Big Y, enhance the manliest thing about you now. Oh, your capitalism. Your That's true though. Your capitalization is on point. With scientifically proven proteins that lengthen the telomeres in your body. Big Y rhymes with big lie. But don't think about that. Order now. Oh, creatine. Yeah, creatine's another one. Yeah, like We could call it like the big Y movement. We were going between little y and big Y, or like, you know what I mean? Like suggest that the Y chromosome is shrinking, which is not. Well, it's not in a meaningful way for our species, or not our species, but for the existence of the male sex. But small y kind of is the opposite connotation we want. We want them to think big Y. Because the obvious logical like next step in like the thought process is big Y, big penis, right? That's the mental gymnastics we would want our manosphere rubes to make. Shouldn't call them rubes. Honestly, I feel as a man, as a man, I feel bad that we have such a toxic masculinity based culture that the manosphere exists and thrives. And I would not actually do this because I would feel bad preying on people who I just kind of wish would seek mental health, like experts and healthy relationships with themselves and other people. For real, now it's fascinating how many supplements advertise with having rare plants or DNA activating properties. Yeah, that's definitely a big one. DNA activating. I'm just curious what Alibaba sells on that. I've definitely seen it before. I was gonna have it be a stream title once, or stream. Oh, a stream. Sorry, I just got distracted. A stream. What am I trying to say? Theme once, but it was like, a little too not interesting. There are some parts of your DNA that do not need to be activated. Yeah. Skincare? Oh, this Dr. Salmon? Wait, no, Dr. Skin Control Ampule. You're right. I like these. Uh-oh, Stem Cell Booster Ampule. I like the word ampule. Big Y chromosome ampules. Wait, what? Stem cell booster ampule for anti-aging with dermapen. With moist, elastic skincare. Oh, wait, show me that picture. Oh, do you inject this? Oh, it looks so cool though. Salmon DNA and EGF complex. Uh-oh. Uh-oh. Oh no. Gotta zoom in here. Yeah, I love the SEO titles. EGF complex whitening ampule whitening. Oh, skin whitening. Salmon DNA component, which acts as cell proliferation, damage cell regeneration, anti-inflammatory, and components that help to improve wrinkles are promote the function of skin cells and help improve skin texture. Stem cell culture medium that gives excellent effect on wrinkles improvement and whitening. Okay. Interesting. Go away, honey. I don't need deals on this. Oh, here we go. Oh, sorry. Uh, you gotta say though that it's non-GMO. Yes, natural, non-GMO. Claims made, not endorsed by the FDA. Yep. Then I would get everybody. Hello, Reasonabe. Gluten-free. Vegan, or is that going too far left? I don't know if the manosphere likes veganism. Yeah, honey's just all up in here with their stem cell booster deals. Uh, Reasonabe, we're so off topic. I'm seeing if I can sell the manosphere supplements to increase Y chromosome length. And then I ended up on Alibaba looking at Dr. Drawing Stem Cell Booster. And now here we are. Okay, what's EGF? Phytoplacenta conditioned media. Ooh, soybean. They won't like that. Soybean. We're not soy boys here. Oh, okay. Okay, I don't want to know. I don't want any of this. I'm so. They like to literally eat liver, so you don't know about vegan. Yeah. Yeah, I was looking up that, DNA activating. Oh, zinc. Yeah, you could just sell zinc supplements as Y chromosome lengthening. MTESR? I am unfamiliar with what that is. MTESR. Ah, see, I'm not a human cell person. It's a cell medium, which is extremely expensive. But see, I could repackage this and sell it that way. Yeah, I don't do stem. See, this is real. No, 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 no. Unless stem cell media. Does Alibaba sell 55-gallon drums? Oh, they do. Oh, 600 for a liter. Ugh. But still. Hi, Brian. Just tuning in. What sort of rabbit hole led us from coding to Alibaba Y chromosome lengtheners? I was telling everybody about my newest scheme, which itself, the coding, like images into genes itself was a scheme to get Elon Musk to pay me a ton of money. I need to finish one of these schemes. Uh, yeah, it's someone in another lab that I work next to. We came up with a scheme to sell the manosphere uh, Y chromosome lengthening supplements. I feel like we make a lot of money. Yeah, it's expensive. Quantity of liter. Yeah, it's expensive even on Alibaba. Although, look at this wholesale media pieces. Wait, is this $3 60 per 500 mils? I mean, honestly, if the stuff isn't just like wow. Do they sell methylene blue? Probably. I mean, you could probably get that just like as a generic, like what is that? Ick, uh, fish like that, like for fish. Where's that malachite green? Ooh, delicious large golden eyes, Japanese frozen red paku fish. Okay, I'm getting just literally fish. Yes. Fish scales. Interesting. Fish. Hmm. DMEM isn't very expensive. It's the FBS that kills you. You're gonna say that you probably want MTS, MTESR and media from reputable sources. Why reputable sources when you can go to Alibaba? All right, all right, all right. How about this? Fe- fetal cow, fetal bovine, pregnancy test, fetal bovine. Yeah, yeah. FES is expensive. I remember there was a shortage a couple of years ago, and it like just disappeared. How do we get fetal bovine serum? Are these like from cows that are pregnant but destined to be slaughtered? I actually don't know. All right, all right. Not that this isn't actually very fun. Look at this cow. Am I pregnant? She's waiting for her results. Oh, look at all these animals. I have to market my big Y to the masculine dad market to guarantee kids will be boys. Oh, that's I can't guarantee though, but it's that's a good one too. Yeah, byproduct of harvesting cattle. I figured. That'd be good too, Megan, because we could really like neg those men because I guarantee most of the people in the manosphere don't actually know that the sex of their child is determined by the sperm. So I assume a lot of people in that space have interesting views on women. So you could like be like, "Hey, it's your fault that you're not having sons. Take this supplement." Interesting how Wish seems to offer less trash for similar searches. Uh, I feel like, I mean, Alibaba, I'm pretty sure is the wish.com of wish.com. So I think it's just like a little, like a couple, another step deeper. What if I search biology? I think Alibaba used to be better because now they just kind of sell actual things. Actual things for realistic prices in addition to just crazy amounts of strange things. So it's hard to find the weird stuff sometimes. David, I'm not sure. I totally just an impression thing. I swear that Alibaba was kind of like the weird one. Can you buy live insects? Biology is just microscopes and skeletons. The two scientific genders. Interesting. They do not explicitly sell just live insects. Alibaba is where you get your fake sports jerseys. Wish is where you get your fake wedding dresses. Can I get a Tom B- Bordy jersey? Will they accept something that's just misspelled? Ah, name. My favorite team. My favorite team name. They're any name. All right. Okay, I want to code now, cause. Oh boy, I have a to do. Oh yeah, we named the functions DNA de-imagase and DNA imagase. Cool. All right, so we were doing gray boat, make that a gray boat, convert this to a data frame, and then we can plot that. Okay, so do a head of df DNA. Yeah, so it gave us a plot. Right. So it's all these values. Oh, wait. Currently, chunks, gray value into 1/4. You want to convert 00 to 99. I want to convert 00 to 99 to AAATTT decimal to quaternary. Now, I feel like that's not right. No, I feel like I changed something before. Let me look at these. First of all, let's look at this emote. How do I print? How do I print an image? Plot. Plot emote. There we go. Yeah, because that's what we really want to do. Very cute. Grayscale that. Oh boy, I was really up to some stuff, and I did not at all write down what I did. Okay, so df turn. I see. Okay, so I had. So what I think I was doing is I was converting these to ternary, head of df turn. What does range of what is I just need to find the full range of these, and I'm pretty sure this is what I want. 3 and 25. That's not right. Okay, maybe I actually need something that's not this. So I'm gonna go back to the boat. Give me boat, please. Boat, 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 boat. Okay, cool. Oh, wait. Head df turn. Range of df ternary at value. Is that the minimum and maximum? I don't think I know what this function does. I really should. Range. Give me what it does, please. Oh. I'm pretty sure it's giving me the range. I think I'm doing it right. Okay, so this. Okay, right. This is where I wish I had. I wish I had my explainer. Oh, wait. I could just pull up the YouTube page. I think. I might not have this actually released yet because I've been very slow to actually release the videos from stream. Let's see. 54 people have seen one of my videos. Why? I mean, great, but also why? 73 people watched the video of me extracting wasp larvae from a caterpillar. What's going on here? Am I missing things? Let's see. Does anyone have any recollection of when I did this last? I don't. I have no clue. Oh. Wait. I don't understand what that means. All right, now. Okay. You've been so stressed, you thought You only had 6 days of leave, but you have 10. Oh, that's nice. You're back and much more calm. Okay, what am I trying to do? Yes, yeah. Well, off screen, I was trying to find a previous stream recording of where I explained what I wanted to do because I have a very poorly drawn out little thingy right here. So basically, this image on the right, I've converted it to gray values, and actually, so if I do, I think if I do plot df turn, we'll actually see the converted. Please? No, it didn't. It wasn't happy. I want to convert this to DNA sequence, right? So I want to do that using ternary, so not binary, not quaternary, ternary. So every gray value will have 3, you know. So 000 might be, oh, it tried to print something. I'm not sure what that is. I'm going to remove the current plot though. There we go, boat. Okay, so basically every single pixel on this image will have either the value of like 0 all the way to 25. Okay, and those can be represented by 3 bases, 3 times 3 bases. So A, T, or C, either in the 0, 1, or 2 position, right? Okay, so that's just like a bit of, I don't know, conversion. So it's more pixelated, less information than the original, but that's fine. I'm trying to do this because I want to turn it into DNA. Next up, I need to find a way to keep the dimensions of this image. Okay? So the way I came up with that is by having a grid system where even though each value is ATG, or sorry, ATC, three letters, they all start with another one. ATCG, ATCG, over and over and over again. Okay. And then, so that would convert it basically to a matrix of 4 letters, which are the first one is a position information in the row, and the next 3 are the value of the gray color. Okay, great. Well, what about the fact that this would be a chromosome in length? Not really, but huge. Even this just little boat picture, it would be huge. Well, then we need to start shrinking down the amount of information. So the way I do that is by having a special case where somewhere, oh boy, where I basically introduce G's. So I use G's as a like special character. So if I get like a G after an index, that indicates that a certain number of pixels that follow are all the same, hopefully reducing the total length of the DNA. Anyways, if I can do all that, I then should be able to get a linear sequence that represents a full image, as compact as I can make it as like currently imagined. Finally, I take that and do it the opposite. Convert everything back, opposite wise, back to an image. So if I can do all that, then potentially I can get a fun little sequence for any image, you know, a meme, a photo, whatever you want, and throw that into maybe another program that I'll probably just find for R to find like the optimal target for homology directed repair to insert images into the human genome. Not for real, but for fun. And then I'll sell this script to Elon Musk because he loves memes and he loves stupid shit. and maybe he'll pay me money for it. I don't know. Did that make sense? Because my code is very bad and also not well annotated, so I don't even remember what it all does. So let's just see what it does. Okay, so for I in that. So I'm doing something right now. So for every row in this, I take the value of the converted turn. So it's data frame underscore turn. So data frame as ternary. The value at that, and I convert that into DNA array. You gotta go do your own cell stuff. Yeah, absolutely. Good luck. Don't kill them. Don't contaminate them. Have I looked into the apply function? Yes. It absolutely would speed it up, but my brain is not tuned to use any of the apply functions. I want to do that after I kind of get the bare bones. I know it would probably be simpler to just do it ahead of time, but I feel like I need to like the combination of me talking about what I'm doing, me responding to chat, and me actually trying to code when I am not like primarily a coder makes my brain dumb when I'm trying to actually think about what I'm doing. Okay, so I'm converting something. Yeah, so I convert this. I keep it as saved, so I'm going to go ahead and do that so I don't have to reconvert it. So let's check head of saved to see what I did. Ah, there we go. Okay, DNA array. Where is that? That must be a, I must have written a function somewhere. There it is. So this function, okay, this function to convert base 3. Oh yeah, look. To base 3 default into DNA sequence, ATC only. Okay, cool. Oh yeah, I would love some help. If I get stuck and or if I finish and need to make it, my phone is buzzing, to make it more efficient. Okay, but look, so I've already done myself a favor. So now I have this image as a preliminary DNA sequence. And actually, yeah, if you look at that, see, this is what I mean. Here, let's do head of saved. Is it N? Row? I just want 10. How do you do that? There we go. Yeah, so like the first 10 pixels already, they're the same gray value. So definitely could save a lot of space if that was just represented by a fewer number of bases. Okay. I left myself a handy little note. Can't be encall find fix. So what am I trying to do here? For everything in each column. Wait, what? Why am I doing things for each column? Max of X. Okay. Ah, I see. So the max of the I should have explained this data type. So the way that R is keeping these images is simply by an X value, a Y value, and a value for the gray color. So now in this function, I believe what I'm doing is I'm finding the length of the rows and then, the length of the rows and the number of columns as sort of a space saving thing, as part of the space saving thing, right? Because we have to also encode dimensions into the sequence itself. Okay. Find dimensions of image. Although I don't know exactly why I don't just do that by itself. What am I actually doing? So max x, max equals this. Yep, okay. Row end is set to false. Column start, if else, this modulo 3. Oh, what am I doing here? What? All right, I don't actually know what I'm doing. Yeah, see, I would just use dimensions, right? Oh. Hold on. Max of, whoa. Max of saved at x. Yeah. I would not, maybe not dimensions. Yeah, so max of saved at x and max of saved at y would give me the x and the y. I don't know, I'm not sure what this does or what I was intending for this. So just gonna keep that, put that aside for now. So raw seek. I believe this means that I was starting to actually make the sequence. Okay. So for every row of this, I get the row index, which is this at y. Okay, I have a counter. Okay, so I think this is where I try to sort of pare down any identical values within the same row. It gives you your bounding box for your 2D image, right? Yeah, so if I just get the maximum value of column X and maximum value of column Y, I would get the dimensions of the image, right? Yeah. So I definitely have that. So I really don't know what does this do. I really don't know what I meant by this. So we're just going to ignore that for now. Okay, so I start a counter. So if I is less than the number of rows, oh boy. You know, what if I just run this and see what happens? How about that? Let's see what happens. It's going to run for a while. Because the intention, though, is the next step is basically, oh, it gave me something. Oops, not that. End character of raw seek. Okay, so I have something that is 82,000 DNA bases long. Okay. Okay. Is that okay though? 82,000 bases long. I see it over here. So it says CAC. Oh. Ooh, yikes. CAC, so that is clearly the first value. ACA, what the heck did I do? This is what happens when you don't properly annotate your code. You come back to it 2 months later with literally no idea what it does. I converted the sequence into something, but then it's super repetitive. So I'm pointing at my screen right now, but if I hover over this, you can see sort of halfway through, it just becomes A, C, 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 A, C, 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 C. Rizanabe, another thing I was attempting to do was to try and account for the fact that if I wasn't careful, I would get huge long strings of the same repetitive bases. right? So that was the thought about using G and using those indexes, ATC, ATCG, so that no matter what, I was guaranteed to always mix it up a little bit as I was going. All right. We got to break this down. Okay. If I is less than the number n row df turn, n row df turn. Oops. Why was I doing that? Why was I asking if I was less than n row of df turn? That's what the for would do, right? Or am I just, did I maybe find, was this my quick and dirty way of avoiding doing something on the very last one? Okay. Something, I was doing something. If substring, okay, here, let's test this out. So substring, by that I mean substir, df turn, value at, let's say we're on the 10th, 2 to 4. Oh, because I have it incorrect. AC. Okay. What is df turn value at 10? CAC. Have you identified a way to do what you want for a single instance? Break it down into its simplest piece and then build up from there rather than digging through the nested loops. That's what I'm kind of doing right now. It's just that I'm very bad at programming. So, shot myself in the foot. I know what you mean. I know what you mean. And you're being helpful. But also, I might not have help to be had. Okay, so what this is doing is evaluating whether or not the value of the pixel is the same as the value of the next pixel, and the counter is less than 15. There was a reason for that. I don't remember why. If so, add 1 to the counter. Okay, so this counts identical pixels. Except it doesn't, because the pixel is CAC, not AC. Hello, Dracula. Welcome. Yes. Well, see, yay comments, but comments should be like done maybe as you're writing it, not 2 months after you've written it and have forgotten everything. Okay. Maybe should be 1 to 4. Actually, wait, why is that 2 to 4? What is substring of 10 at 2 to 4? 1 to 4, I mean. CAC. Interesting. Okay. So this is counting identical pixels up to 15 in a row. I believe there was a reason for this 15. And I believe that's due to the number of just how much I can count up in ternary. And I don't remember, but I just don't remember that part yet. I'll figure it out. So if the substring does not, okay, if substring, so you're counting, if the substring you just grabbed is not the same as the substring at the next one, or the df turn at y is greater than the row index. I see. So this is asking itself, okay, I see, okay. So check if the pixel is different from the next pixel, or if the next pixel is on a new row. Okay, that's making sense. And now, now that I'm thinking about it, I don't think this 1 to 4 is correct. I believe I had skipped a step at some part. That is this. This part that I was trying to figure out what it does, I believe, yes, it's pasting the column index. I'm missing sequence. That's why. So that's broken so far. Okay, but I'm on a roll with figuring out what these do. So I'm going to keep going. So, or if the pixel is on a new row, because if it's on a new row, I don't want to concatenate the pixels quite yet. Okay. So if it is that, then if the counter is greater than 0, then raw seek, so that's just my growing sequence. I paste on the previous growing sequence. I paste on a G. I paste on the counter. That's why. Okay, so this is why. So 15 because of ternary encoding in future step. I get it now. Okay. It might not be pretty, but I was thinking, I think. So yeah, I set, actually, I set it to quaternary. Interesting. I'm mixing quaternary and ternary depending on where I am. Yeah, it'd be ternary because I use 3 bases to encode pixel. Quaternary because I encode 4 bases for the index. We'll figure it out. Okay. So I put a G, which is like telling myself like, hey, you're about to do something weird. Yeah. The G is the special character. And then I encode, wait, quart2 DNA, dec2 quart counter. Okay, I got to check this. Counter is going to be 15. So if I do quart2 DNA and dec2 quart of counter, all right. Apparently that's 15 is CC. Maybe a dumb question, but why do the x/y coordinates of the pixel matter in this case? Will the compression not compress if you move from line n to line n plus 1? That's a good question. So I think in my mind it was a way to make it so that you could go from so that you wouldn't have to encode the size of the image elsewhere for when you're decoding the image. I'm sure there's probably a better way to think about this. I think in my original version I did hard encode the size of the image as like a preliminary sequence before the sequence of the actual image itself, like the gray values, and that was just like super unwieldy for even a slightly large size picture. So this way I'm just kind of doing a trade-off. Yes, I'm saving less compression space so far, but then you can decode the image completely without knowing the dimensions. That said, I'm sure there's a clever way where I can have the best of both worlds, as in do it the way you're suggesting, but then I still just don't have to hard code in the size of the image. That was also part of the indexing thing. Okay, there's this side thought to myself. Um, the indexing is also so that you can tell whether or not you've lost any pixels, which is kind of dumb because in this case you don't really like if we're doing this all computationally, like that's not going to happen. But I was thinking like in the case of like actually putting this in DNA and a value changing. Um, I think I had recently watched something about how data integrity was maintained. So then I had this idea that, well, if everything starts with an index number, then you can tell maybe if something was sort of like off. Totally unnecessary for the actual practicality of doing this just on the computer. But I was trying to code in something so that we could tell if we made it actually into DNA if something changed. The size is fixed y and the xy coordinates, right? So you're just iterating over the third column and can reconstitute the image based on the xy coordinates. The image is fixed per image, but I was hoping this to be applicable to any size image. You're still right. You're still right, though. Still, I could hard code in the size. See, now you're making me double rethink this. So would it save more space? Okay, wait, I think this might be a moot point though, because I'm still trying to keep the counter less than 15. So I feel like it's a fairly small amount of information that is added by not just going from one to the next. Okay, I'm going to keep going how I'm going now, but you are raising all the correct points. Okay. So, okay, if counter is greater than 0, so this is then encode the number of identical pixels in a row on the same row to the growing DNA string. Reset counter. It would be you don't need to hard code it in. I guess I'm confused at what we're saying. So what I'm saying, oh, you don't need to hard code it in. So when you say when you read it in, you just check the dimensions of it. Read in the image or the DNA. I'm concerned about going from DNA to image, not image to DNA. Okay, so if the counter is not greater than 0, then you are just adding it on. Okay. So, oh yeah, and so yeah, and if you and here's where I'm like, if you have the end of a row, then you are just adding in G. Okay, wait. So actually, I would think I was farther than. So yes, in this version, I definitely am not hard. Okay. Yeah, coordinates are coordinates. I feel like I'm not picking up what you're putting down, and you're probably giving me a much better way to do this than I am currently doing it. Let me finish with these thoughts, and then we'll come back to your idea. Because I think I was actually closer than I thought to actually finishing this iteration. Oh, and Rizunave, great suggestions, because version 1 was god awful. It's like, oh, do you want 20,000 C's in a row? Here you go. This is better, but I feel like you're describing how we can make it even better after this. Demarcates end of row. Yes, yes, absolutely do that. Absolutely do that. Okay, so I'm pretty sure what this does is this bit up here. What this does is set index per pixel per row. So what I want this to do is be like ACT, oops, ACT, ACT, and then on the next one it would be the next in the line, CTA, CTA. Next on the line is TAC, TAC, and then back to square one, ACT, ACT. So that it would always follow this pattern so that you would know if when you decoded it, if something was off. See, now I'm understanding like why this is probably a dumb way to do it. I already knew it was a dumb way to do it, but not how dumb it was to do it this way. All right. Okay. Regardless, so max x is what is, okay, max of df ternary at x, so that's just going to be the maximum row. So that's the number of columns. Number of columns, because it's the max value for x. Because y, I think, is the row. Oh wait, for I in 1 to n. No, that's dumb. Shouldn't this be n row? Why am I doing it for columns? Columns would just iterate through x, y, and then value, and then that would be it. And row. I'll check that. So you get the number, the max, which you should only have to do once, so I don't know why I do it so many times. I will actually pop that outside of this. Okay, and then I ask, is the row done? No. Column start, if else. Okay. So I'm doing some modulo things. So that just takes the, that's checking if something is divisible by 3, and then depending on the result, just saving the column start. Right, because since I'm going, I basically have 3 columns, either start with A, C, or T, and then I repeat. So that's what this is doing. Yes, yeah. So I either figure out if the column starts with a 1, a 2, or a 3, 1 being A, 2 being C, 3 being T. Okay. So I gotta write that down. Decide which version of the row indexes are used. I.e start A, C, or T. Okay, so while we're not at the end of the row, the value is at J. Oh, I see. Okay, that's why this was columns. Oof, that's tough. See, I knew what I wanted to do because I want to iterate through each image row here. Okay. So encol was wrong, but and row is also wrong. I'm checking Discord every once in a while. Reasonabe. I'm excitedly waiting. Okay. So while we are not at the end of the row in the image, we take the column start, call index. Yeah, call index of column start. So I'm basically just picking which index from here. Just check to make sure that's how you do it in R. Yes, okay. And then the value. Okay, so I'm just adding it, then going +1. And then column start if else. If column start cool. If the number is at 3, you go back to 1. If it's 1 or 2, it adds 1. So that's just iterating through. I see. And then this is why that max number is important. If we reach a row and its x value is greater than or equal to the max, then the end row becomes true. And then you pop out of this and start the new row. But you start at I, and I needs to be I get it now. Okay. I needs to go back to, not back. It needs to be the total number of rows that we've gone through so far. Because you basically skip everything and are popping down. You're popping down image rows, which is a problem because the number of rows is determined by the number of columns in the image. Posted your idea. Got it. This is what you're trying to describe. Okay, I hope I'm not too stupid to understand this. But thank you for taking the time to write this out. Okay, so the first 3 rows are the image, right? So this is like the encoded image. Is that what you mean? You know that it's 3 rows and a maximum of 13 columns, each column being an individual base. Okay, so you're just making it simple on me. So we have 4 colors. You can I hope I'm not too stupid to understand this, the daily mantra of most researchers. Yeah. Also, hello, James. Okay. Then you can make this assumption that actually it's, A, T, C, G, A, T, C, G, blah, blah, blah. And then even though we go to another row, yep, this can all be read in initially if you convert the FASTA file or whatever to the image, allowing for an abstracted form. The benefit is you'll only ever have to operate on the 3rd column since the coordinates of the image are fixed. You may be misunderstanding things though. Okay. Okay. You have an unequal number of. Okay, but you were doing that for my benefit, right? Unequal number of columns per row because you're assuming I want to shorten things, right? You know, I think you are. I think you're right. I think you're right. I was thinking about this too hard because, yeah. Okay, I'll make a deal with you. I'm going to think about this because you're absolutely correct. I do think that this is. Oh, that's just how chromosomes. See, I was thinking about this in a single string. Like, you know what I mean? This is like we take an image, like I take a picture of myself, I put it on there, and I turn that into DNA. No separate chromosomes, no nothing. One linear string of DNA that just happens to be super long. I still think you're making a good point that it is still better to, at the beginning of that, just hard code in some sequence that represents the size of the image, and then completely just not worry about having to code that into any other place in the DNA sequence that I'm dealing with. Okay, this astute observation is definitely going to be part of version 3. I understand completely what you're saying now, and you're absolutely correct. All right. So, but I still want to finish this version. I'm so close. I'm so close. I almost had it. Okay, so basically, this for loop needs to count by head of df turn. Okay, it needs to, for every single row, go through it. But then when it hits a new y value, meaning a new row in the image, it needs to update everything. And so the for loop will go from like for 1. Why is this so hard for me to conceptualize? My brain is telling me how to do it or what to do, but I can't say it out loud. So what is the problem? Maybe if I just describe that. So I get the maximum number of x, which is simply the maximum number of columns. Easy. Then I iterate. Nope. I first start at the row at 1. And I decide which version of the row the indexing I'm going to use. Start with A, start with C, start with T. Got it. Okay. Once I decide that, then I go through all of Y. So once I go through all of Y, I'm doing a bunch of stuff, adding some sequence. At some point, I test to see whether or not I'm at the end of Y. Basically, whether or not Y has become a new value. I'm doing it a bad way here, but I could probably change it to test for a new value. Okay, so I test for a new value, and now it's different. So now I know that I have gone through. Okay, why did I do it this way? This is stupid. Because once again, oh, whoops. Back to the obvious idea that I already know the number of rows and columns in this image, because I can just get that. So how many times do I go through? I go through max number of x times. And then how many times do I do max number of x times? I do max of df turn at y. Duh. Okay. 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 We're getting somewhere. And I also understand this is just a bunch of nested loops too, because I could definitely make that better. Okay. So yeah, I don't need this J nonsense. Yeah, because this is just testing to see if I'm at the end. Okay, okay. We're gonna change this to a for loop. For nope, for j in, because this is going by, yeah, this is going by x's, by x. For j in one, actually here. How do I grab, so df turn 1 to 2? That's not correct. That's not what I wanted. Although it did give me the information I needed. Just double checking some stuff. Always starts at 1. Yes. For 1 in 1, 2, max x. Yes. Okay. Then I don't need that because it will automatically update. I'm just going to delete this. Even if it worked before, I don't want it. That's a bad way to do it. Do not need this. An extra somewhere. Okay. So, yep. Okay, cool. I don't need this J either. So I basically just need to decide for I in 1 to max y. So that will go 1. Wait, yeah, is that it? Is that all I had to do? Okay. Head of df turn. Okay, great. Got this, got this. Let's see. Oh, I don't need row end. Let's just see what it does. So I can take another bite of my Chipotle that I've been eating slowly for almost 2 hours. So thank you everyone for sticking in. Currently, I mean, via my view, 12 people. It's pretty amazing for me just poorly typing out stuff on this R code, but that's awesome. Much more interesting content tomorrow. So this is day 2 of my streamathon, where I'm just attempting to make it a little bit quicker to unlock those free emotes for the community. But I do appreciate people coming, because what's even sadder than me sitting here and struggling with my own code, it's me sitting here struggling with my own code when no one's watching. So I appreciate it. And I feel like if it weren't so utterly dangerous and prohibitively expensive and probably illegal, I'll just like fantastic, like god tier Twitch chat reward would be like, I'll convert any image you give me into DNA and inject it into my cells or something like that. All right, it finished. Head of df turn. Oops. Whoops. I've broken something. Interesting. Okay, I obviously, okay, ooh, whoops, saved. So df turn is going to be now recovered from saved. There we go. Good as new. All right, clearly I was iterating somewhere too much because there's my CAC, but I added a bunch of C's and A's in front of it. So let's just say that I is 1. So let's do column start. Col start should be A or 1. Yep. Actually, it's probably more interesting if I do I is like 10. Oh, shoot. Yeah, okay, that's right. That should be right. It should be 1. It should only go by 1, 2, 3, 1, 2, 3. I see. I see what I did. The next logical step, create DNA that codes proteins shaped like objects, 3D sculpting, molecular style. Okay, you know what? People are not necessarily doing that. Okay, this is a good rabbit hole. Taking it. Let me save my work. Okay, so this is DNA, not protein. But there's this stuff called DNA origami, which I don't have access to. That's fine. We'll just look at the pictures. Where people, here we go. And I'll move myself out of the way. Where people are using the fact that DNA base pairs with itself, right? DNA finds other DNA to make shapes out of just DNA. Now they have good reasons for this, but they have actually done like this is the shape that they were creating or hoping to create by making all these different bits of DNA that anneal or join to each other in different arrangements to make all these different shapes. So that's one level. This has been done for a couple of years now. It's not too exciting. Oh, Mobius strip. But now, custom protein AlphaFold. People are using AlphaFold to design proteins. So DNA, easy. It's pretty easy to sit down and if you really work at it, design a 2 to 3D-ish image that you can make out of DNA. Protein is way, way, way harder, but with this new program we have, this new program that is the more famous example called AlphaFold, we can actually predict pretty well the shape, 3D shape of a protein. So on this pixelated image, blue is the AlphaFold, so that's predicted, and then green is actually the experiment where they tried to figure out the shape of the protein. And they overlap pretty well. So this is like looking at a small subsection. Then in the middle panel here, it's at a very, very close section where there's this ion that needs to sit here. This ion is being coordinated by these different amino acids. So these amino acids are also in the right place. And then a sort of zoom out of a larger structure, which is a little bit more chaotic, but still pretty close. I mean, this is pretty awesome that we can do this. It's through like AI and stuff. So yeah, you put in an input sequence and then it cycles through giving out 3D structures. So people are attempting to create custom proteins with specialized functions by basically doing this. Design, iterate, spit it out, see if it's what you want, and then make it in real life. It's pretty cool. AlphaFold irks me a little bit. Just because they put it on my field's like main database and all of the predictions are awful from the proteins. They look like spaghetti messes. What's this little guy? Look at this little guy. I don't know who this is, but you know, he's thinking about a protein. Anyways. Okay, so clearly that for every x, I did something too many times. So df turn value at j, so df turn value at like 5? Yeah, okay, at 5, it does something. And then I see, this is the problem. Okay, so then j, no, I needs to now equal I plus, no. Maybe this is a while loop. While no. Back to this question of, so I need to go through every single version of y. So this I isn't just going to be 2. What it has to do is jump a whole x, a whole max x. So this is not that. This is n row. This is back to n row. N row of df turn. We're starting at 1. And what we are doing is the guys who want to store information in DNA as a long-term information storage system is pretty cool also. Sort of like this image, really. Yeah, this is this image that I'm dealing with, or that image that I showed, because either way, they're about the same. Like in terms of, like, this is not, what I'm doing is not a novel idea, but yeah, it's a cool idea. I feel like I have, and actually, James had suggested this book. What is it called? Quantum DNA book. It's now next to my bed. That did not bring up good looking. James, if you're still there, remind me the name of the book. Life on the Edge. Life on the Edge. I think there's a bit about storing DNA in there. Yeah, the idea in general. Oops, my face is in the way. The idea in general is super cool. I want to read this book. I think it has a bit about storing, actually maybe more than a bit, about storing DNA or information as DNA. I have some, I mean, there are technical limitations and feasibility limitations, but, you know, maybe someday. There's also the group that encoded a GIF into bacteria using one of the Cas systems, which was pretty cool. And it was probably not as, they didn't make it as hard as I am making it for myself. Okay. Okay, so while I is less than or equal to n row of df turn. Okay, so what is I going to be? I is at 1. Then I is going to be I plus max x minus 1 because it's kind of off by 1. Why is this unexpected? This shouldn't be unexpected. All right. I don't think that will work quite how I want. We'll check it out. Maybe. I feel like I'm very close to like finishing this iteration though. If I can just get these indexes, I mean, I have to write the whole reverse sort of bit of code, but I feel like it's more worth it to me to get a happy forward set of code before I make the reverse, because otherwise I'm just doing double the amount of work if I'm not happy about the encoding system. So yeah, does anyone have any other any ideas of how to reduce the amount of information? So I want the maximum number of pixel values. Right now I'm down to 25. So, you know, this image that you see now of the boat has 999 pixel values. And I reduce it to 25, which surprisingly is not the worst looking. Okay. Still doing something wrong. Hey, it's doing the indexing though correctly. It's iterating through it, so that's good. So what is I at? N row df turn. Okay. Okay. So why are you adding things? Why is it not moving forward? Turn. Oh. Yeah, because it's not iterate. Yep. Okay. For J, will it accept 4J? No. From I to max. So the problem was that it was just restarting back every time the y value restarted, the x value restarted. So it was just adding everything to the same columns over and over and over again. I think I start though at I. Right. To I plus max x, because I want to shift it, right? So I have, you know, go through the first 10, and let's say that's the end of the row. It then needs to pop down and go through that 10, pop down, go through that 10, etc., etc. You know what? I'll just do it. Why did that happen so quickly? Because it didn't work, is why. So really row end, which I used before but have deleted, is I plus max x. So it should, so the first one should be, again, -1. So max x -1. No. Oh yes, because it's plus I. Shoot. Have I ever heard of the Huffman compression algorithm? I think, at least you think it's Huffman. You collapse strings of common values into value number key pairs. For example, you could condense AAA, TTT, GGG into A3, T3, G3. You could also do higher level combinations. Yeah, so that's sort of what I was getting at, but I guess my problem is that I'm not starting from DNA. I'm starting from number values, putting it into DNA, and then trying to compress that DNA more using only letters from DNA, only ATGC. So I can't, for example, do A3. I would have to do AAA or TTT. You know what I mean? So that's why I sort of have it in here, right? So another part of this is like when I find identical pixel values, I give it a unique identifier, G, and then I convert the number of identical pixels into DNA sequence, a 2-value DNA sequence, and then add that in. So I don't think it sounds like it's this suggested compression algorithm, but I will write that down and look it up and see if I get any ideas. Huffman, you think it is? It's still not working. Head of DF turn Y. Row end. Oh, whoops, that's why. Because I didn't reinstantiate I. Reinstantiate. Just put back in I. All right. I think, though I am nearing the end for today. I said I was going to stream for about an hour and a half, and it's been 2 hours. Didn't get as much coding done as I thought I would, but that's totally fine. We went off on a tangent to begin for a while, and that's totally fine. I just want to see if this works really quick. I don't think so. I think it's still going to be a little iffy. I think what I want to do is next time I'm doing coding, I want to come back with a finished product that actually gives me a string. I'm going to read up on some of these suggestions, and maybe I'll just talk about it on the Discord. And maybe we can come up with a iteration 3 that is more efficient. Because at this point, oh. Okay, at this point, oh, hey, I did it. It works. Hold on. Cool, that absolutely worked. It came out with an error, but I'll fix that. At this point, I believe if I just run this next bit of sequence, I hope it doesn't break. I believe I can make a string of DNA sequence that is technically these pixel values, right? But the question is, how small is it? Hey, there it is. So if I hover over this, okay, so we have TCA, CAA, C, GGGG, AC, 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 ACT. Okay, this is also good. Got a low complexity, a lot of low complexity though in this bit. The issue is nchar. This is probably going to be what, 100,000 bases. Almost dead on. 112,000 bases for a relatively simple looking image. So that's sort of an issue, right? Let's see. Yeah. So to make this functional, to make it workable, how do I check just the like first, substring raw seek. Let's do 1 to the first 1,000 bases. Yeah. So have to turn this chunk of DNA, which itself, I think something's not quite right. Like it's it's still repetitive. I feel like there should be more, there should have had more compression. So that's the end of the, oh, you know what? Something on the compression isn't working. So that's an end of a row. That's an end of a row. And then the next end of the row doesn't happen until there. And yet I'm seeing very, very similar pixel values. Those should have been shortened. So something about the compression is not quite working. But beyond that, still needs to be compressed way more. All right. Regardless, I think that's going to probably be it for me tonight.